Hey there, math peeps. This is Mrs. Marshall, and I am here to talk to you about Unit 2, Day 2, dividing polynomials. So, to begin, let's review. So, this should be review, not new, but refreshing your memory on how to divide polynomials with long division. So, step one is you got to remember the setup, and you put the whatever you're dividing by on the outside, whatever you're dividing on the inside. So here's what you're dividing by on the outside. Here's what you're dividing on the inside. And then you put your quotient, how many times the piece on the outside goes into the piece on the inside. And then any remainders left over are at the bottom. But of course, don't forget, you have to subtract to get those remainders. And technically, when you have a remainder, if it's 0, whatever you divide it by, that divisor is a factor as long as your remainder is 0. And so I'm going to do remainder in blue since I highlighted in blue over there. All right, let's do a full-on example so we can refresh our memory completely on how to divide polynomials with long division. So here's our first example. Find the quotient and remainder using long division, then state whether the divisor is a factor. So our divisor for this first one is x minus 4. We're trying to figure out, is x minus 4 a factor of 6x squared minus 26x plus 12? Okay, so let's divide it. X minus 4 on the outside, 6x squared minus 26, don't know what that is, 26x plus 12 on the inside. And now let's divide. But one thing to note, your exponents must be in order from increasing to decreasing, and none can be missing. So you got to start with 2x squared, that's the highest exponent, and then x to the first and x to the none. And we indeed have that. So we are good to go. So let's divide. Step 1. The number on the outside, your first term, has to go into the first term on the inside. And now the question is, how many times can x go into 6x squared? So in other words, what times x equals 6x squared? And the answer is 6x. So since 6x is our linear term, we put it above the linear term. And now we multiply. 6x times x is 6x squared. And then 6x times negative 4 is negative 24x. And we line it right on up underneath the term with the x. But now we have to subtract. So don't forget, you got to turn all these opposite when you subtract. So subtracting a positive is a negative, and subtracting a negative, it turns into a positive. And now we solve it. 6x squared minus 6x squared, that goes away. And negative 26x plus 24x is negative 2x. And then don't forget to bring down what's left. And we start all over and we do it again. So this time, how many times can x go into negative 2x? So what times x equals negative 2x? Oh, it's negative 2. And so then you put that at the top. It's a constant term this time, so you put it above the constant term. And now we multiply. Negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. And don't forget to change your signs because we're subtracting. So subtracting a negative is positive. Subtracting a positive, I scribble that out, is negative. And so solve. Negative 2x plus 2x goes away, and 12 minus 8 is 4. Now the question is, how many times can x go into 4? It can't. It cannot go into 4 because the degree of x is 1, which is higher than the degree of 4, which is 0. So 4 cannot be divided by x, and so therefore that is our remainder. And now the question is, how do we write the final answer? Well, I think of my final answer in a roundabout way. I start with what's on top, and I go in a circle. And this is how you write it. 6x squared minus 26x plus 12 divided by x minus 4 equals 6x minus 2 plus, because all remainders get added, plus 4. But the problem is it's plus 4 divided by x minus 4, because if we could have divided it, we would have divided and it wouldn't have been a remainder at all. Now the question is x minus 4, like we asked at the beginning, a factor? And x minus 4 is not a factor. The reason why it's not is because the remainder is not 0. And that is the second answer. So now let's do example number 2. Same type of situation, but of course something's going to be a little different. And thing number 1 that's different is the fact that this is a trinomial we are putting as our divisor. And our dividend is 8x to the 4th. Wait a minute. We got to make sure we have the right degrees. They got to go in decreasing order. So 8x to the 4th plus 0x cubed. It has to, you cannot miss any degrees. They got to be all there, so that when we add or subtract, and also when we put it on top, it has a correct column to go in. And then plus 6x squared. So 4, 3, 2, minus 3x, okay, 1, because that's the exponent of 1, plus 1, which is none. The only one that can leave off are numbers at the end, but if there's any degrees or terms missing in between, you have to add those in. So again, my degrees are in order from 4, 3, 2, 1, and none. Now let's divide. All right, how many times does 2x squared go into 8x to the 4th? So same little situations, got to equal 8x to the 4th. And so 2x squared times what is 8x to the 4th? Well, that's 2. No, not 2. 4x squared. Well, 4x squared has to go above the 4x squared column, boop, or the quadratic column. And so it goes there, and now we multiply. 4x squared times 2x squared is 8x to the 4th. We already knew that, though. And then 4x squared times negative x is negative 4x cubed. So I'm going to write that there. And, oh, we got to put it in the cubed column. And then 4x squared times 2 equals 8x squared. So plus 8x squared. And now we have to go in and change those signs. Negative, positive, and this positive turns into a negative. So I always scribble out the positives and put a negative underneath or on top, wherever I have room. And now we solve it. These go away, and this is 4x to the 3rd. This subtracts, and that's negative 2x squared. And then you bring 1 down, just like you do in normal division. Bring only one term left at the top down at a time. And we do it all over again. This time, how many times does 2x squared go into 4x cubed? So 4x cubed, and then 2x squared times what is 4x cubed? Well, 2x. 2x is our linear term, so we put 2x at the top. And now we multiply. So again, put that at the top, and we multiply. 2x times 2x squared, we already know that was going to be 4x cubed. That's why we chose 2x. And now we need to figure out what's the rest. 2x times negative x is negative 2x cubed. Not cubed, squared. And 2x times 2 is 4x. And those are my numbers I'm going to write down here. All right, now let's do the same thing. Change the signs. Negative, positive, scribble that out, negative, and solve. These two cancel out. Oh, look at there. These two cancel out. And negative 3x minus 4x is negative 7x. And don't forget, bring down whatever is left at the top. And divide all over again. But see, the problem is this degree is smaller than this degree. So there's no way that number can go into, so there's no way the number 2x squared can go into negative 7x. So we are done. This again is our remainder. All right, and now let's do our little roundabout so we know how to write our answer. Boop and boop. And the answer is 4x squared plus 2x plus, and then your remainder, negative 7x plus 1 divided by 2x squared minus x plus 2. Since we couldn't divide it, we just leave it as a quotient or a fraction. And that's our final answer. Synthetic division is the shorter way to do long division, but you can only do synthetic division when dividing by a factor in the form x minus c. So it can only be an x plus or minus a single number, c. C is a constant. C is a constant. So let's do some examples to refresh our memory on that. All right, we have 2x cubed minus 7x squared plus 5 divided by x minus 3. Step 1, let's set up our synthetic division. You put your number inside, and so technically you're going to divide by the opposite of what you see. So we're going to divide by a positive 3. And then we fill in our answers, or not our answers, our coefficients. So this is 2, because that's a degree of 3. You can't forget about your degrees. So 3. And then we want the coefficient of the degree 2, so that's negative 7. Then we want the coefficient of degree 1. Oh, there isn't 1, so we put 0. And then we want the coefficient of the degree none, and that is 5. So 3, 2, 1, none. And now, let's actually solve it. This 2 comes down, and then you multiply. So 3 times 2 is 6, and negative 6 plus 6, or negative 7 plus 6, is negative 1. 3 times negative 1 is negative 3, and negative 3 plus 0 is negative 3. And 3 times negative 3 is negative 9, and negative 9 plus 5 is negative 4. Oh man, negative 4 is not a 0 like we're used to getting. So guess what? That is just the remainder. It's a shortcut in doing the long division. That is just our remainder. But now we need to write our final answer. So our final answer is 2x cubed minus 7x squared plus 5 divided by x minus 3 equals x minus 3, or technically, you know that's x minus 3. And this right here is 2x squared minus x minus 3. And this remainder is negative 4. Now, the final answer, though, remember, we always start with the quotient. The final answer is whatever the quotient was. And in our case, it's the middle. So our final answer is 2x squared minus x minus 3 plus whatever your remainder is, negative 4, divided by whatever you divided by, x minus 3. And again, x minus 3 is not a factor. X minus 3 is not a factor. And you all know why, because the remainder is not 0. All right. Next one, remainder theorem. So is there a shortcut way to figure out, like, if the remainder is not 0, what is the remainder going to be, than having to do all this dividing? You probably didn't even think that. Actually, I bet you did think that. But yes, there is a shorter way to figure out the remainder without doing all this long division. And the shorter way is, if the polynomial p of x is divided by x minus c, then the remainder is the value of p of c. So you just plug in. So if you are dividing by x minus a constant, plug in the constant, that is your remainder. Let's do an example. In example 3 above, you're going to use the remainder theorem to find the remainder instead of dividing. So remember, the example above was 2x cubed minus 7x squared plus 5 divided by x minus 3. This was the original problem. And so we are going to find the remainder. Find the remainder. Okay, so the first step. What happens is, if you plug in p of 3, well, let's not say if we plug in p of 3. How about if, or not even if, p of 3 is the remainder. So let's evaluate. P parentheses, and I'm going to plug in 3 equals 2 times 3 to the third. I'm going to write that in green though. Times 7 times 3 to the second plus 5. Why are we plugging in 3? Because remember, x minus 3 meant that c equaled 3. And we did that at the top. And so we're plugging in 3, 3, and we already plugged in p of 3. And so your final answer is, well, 2 times 3 to the third is 54. Minus, well, 7 times 3 squared, that's 7 times 9, which is 63, plus 5. And all of that, 54 minus 63 plus 5 is 4. And oh my, look, what? And this is the remainder. And it is the same. It's literally the exact same from above. Let's make above look legible. From above. And we did that with doing the remainder theorem. Again, the remainder theorem is if you're dividing by x plus or minus a constant term, x equals, when you solve it, set it equal to 0, x equals that constant term. When you plug that into the function, that is the remainder. Whatever value you get when you plug in the constant into the function. All right. Factor theorem, which we've pretty much talked about. I've kind of segued it in there the whole time. I don't even think that was the right word to use, but I put it in there the whole time. So C is a 0 if P of X, if and only if X minus C is a factor. And X minus C is a factor if the remainder is 0. So we've been doing this already. Let P of X equal X cubed minus 7X plus 6. Show that P of 1 equals 0. And use this to factor P of X completely. Oh, so this one's a little different. You can't really actually do this one on your own. So when it is saying P of 1 technically is saying that C equals 1. Because when you plug in 1, it equals 0. So C must be 1. So I'm going to rewrite it. Step A, part A. We got to plug it in because it says to show. So we got to do the first part. And we have to, let's do purple. We have to show, and that is, again, part A. And in showing, this is P of X, not X, P of 1. Equals 1 to the third minus 7 times 1 plus 6. All right, plugging that in. And we got to show it. So you got to actually do all the steps. 1 to the third is 1 minus 7 plus 6. And so 1 minus 7 plus 6 is indeed 0. So X minus 1 is a factor. Now, or technically you could do synthetic division. So is in the form X plus or minus C. And in this case, it's minus C. All right, let's do part B. And so the factor completely part is part B. Factor, oh man, I don't want that. Factor completely. Okay. And this is, well, again, C equals 1. So we're going to plug in 1. And our coefficients in decreasing order is 3, 2, 1, none. So for my 3, it's a 1. For my 2, it's 0. For my 1, it's a negative 7. And for the no exponent is 6. And now we are able to solve. Right, bring that 1 down. So let's solve it. 1 times 1 is 1. Add that, and that's still 1. 1 times 1 is 1. And add that, that's negative 6. And 1 times negative 6 is negative 6. And oh, what do you know? It's 0. And so now we have to write our factors. Writing our factors. This first one is x minus this one, x 6. It's always 1 degree lower than your actual function that you're dividing. And so our function we were dividing had a degree of 3, so this one now has a degree of 2. You all probably know that already. But now the problem is we have to factor more because it has to be factored completely more. And so let's factor this some more with headphones if we can. -6. And then we think, okay, what times what? Oh, that's -2 times 3. And so our final answer is going to be x minus 1 times x minus 2 times x minus 3. And because there's no lead coefficient and we don't have to divide by anything, this indeed is our final answer. All right, of course you'll be able to practice this in class. I have one last section, and the last section is the section with the most, but we can do it. Okay, so last section is finding the divisor with a calculator and then doing all the parts that I taught you how to do in the last video. Finding the zeros, the y-intercept, what's the extrema, what's the end behavior, and graphing this bad boy. So technically you have a calculator, but you only have a calculator to figure out what you're going to divide by. Other than that, you have to do all the things, and you can use the calculator to verify, but you have to do all the things without a calculator, or rather show me all the things. And so you're going to use the calculator to graph any polynomial, then find any integer zeros to do synthetic division. All right, so in your calculator, you're going to factor completely, then graph p of x and all of that. So what you end up seeing when you graph it is that this thing looks something like this. Something like this. I think it's like this, something like that. It looks something like that. And you end up having to tell me what the integer zeros are. Your integer zeros end up being this one that's to the far left and this one that's to the far right. The two in the middle are not integers, so we don't want to use those. That ends up equaling, as you can figure out the value of the x-intercept. It's x equals 2 or -2, and this one ends up equaling x equals 5. And so we have two integer zeros. We know, though, that there should be 4 zeros in all. It's literally crossing the x-axis 4 times. But we only have 2 values, so we just use those 2 values for right now. So x equals, this is -2, and x equals 5. It's going through it, so it's a multiplicity of 1, or technically odd, but it's got to be 1, because if we have two more, 1 plus 1 plus 1 plus 1, that's 4 in all. And remember, the number of zeros should be the number of the degree, and our degree is 4. So m, or our multiplicity of 1 again, and so it went through. Now we got to figure out the other ones, like what in the world are those other values? So here's what you do first. You have to do long division. So we're going to set this up with our -2 first. It doesn't matter which zero you use first. I just used the first one I wrote, -2. And then our coefficients. Remember, the degrees in decreasing order. So we have x to the 4th is 1, x to the 3rd is -5, x to the 2nd, x to the 1, and x to the none. And we draw a line, arrow down, that's 1. And now we multiply. -2 times 1, -2, add -7. Multiply, that's 14, add, and that's 9. Or technically subtract, but I say add because then the signs stay the same and you do what the sign says. -2 times 9, -18, add, and that's 5. And then -2 times 5 is -10. And what in the world? Yay, we got 0. We knew it. But here's what you have to do next. You have to divide again. You have to keep going with the other 0 that you got. And if it was a multiplicity of 2 and it bounced, you would have to use that same 0 again, because that means that 0 went in it more than one time. And you would know when to stop when you don't have a 0 as your remainder. So let's keep going. We're going to do it again. Okay. 1 times 5 is 5, so that's -2. 5 times -2 is -10, and that's -1. 5 times -1 is -5, and that is 0. Yay! And so now we need all of the things. So remember, this, because we don't have anything else to divide by, like we don't know what those other two zeros are. There's a weird decimal number, so we have to figure those out exact. So this is x plus 2 as a factor. This one is x minus 5 as a factor. And this right here is x squared minus 2x minus 1. But the problem is, just like before, we have to factor more. Must factor more. And so we think about it. Okay, can we do headphones? -1. -1 times, oh man, that's just 1 and 1. And one of them has to be negative. Both of them can't be negative. So this thing doesn't factor, guys, at all. You're going to have to use quadratic formula. So can not factor, and that's a sad face. Oh, so sad. Use quadratic formula. Quadratic formula. Woo. And that's a happy face. Yay. Because at least I know how to solve it. I know what to do. I might not want to do it, but I know what to do. Okay, so let's solve this. And we are, again, using this one because we don't need to factor the other two. They are already factored. So this is A equals A. Okay, not 1. I mean, not A. A equals 1. B equals -2. And C equals -1. And we do the quadratic formula. Opposite B plus or minus square root. And I'm going to sing it once. B squared minus 4AC all over 2A. All over 2A. And that's what we get. Yes. And now let's solve it. Solve it all the way down. 2 plus or minus the square root of, and the inside after you solve it is 8 divided by 2. Well, what ends up happening, you got to take that square root of 8, that special calculator, folks. If you had that special calculator, it would go ahead and tell you that the square root of 8 is 2 square roots of 2 divided by 2. So this part now simplifies to be this part. Nothing has changed, honestly, from the beginning. Like this part at the beginning just went down and simplified the square root of 8, which went down and simplified 2 square roots of 2. And now you have to simplify more by taking out the GCF. So 2, 2, and 2 go away. And our final answer is 1 plus or minus square root of 2. And those, or that, folks, those are my other zeros. 1 plus square root of 2 is a 0, and 1 minus square root of 2 is a 0. So factored completely. Factored completely is x plus 2 times x minus 5 times x minus, because we always take whatever our 0 is and we subtract it, or we do the opposite of it, minus, in this case, our 0 is this 1 plus or minus square root of 2. So I'm just keeping in parentheses, 1 plus or minus square root of 2. And then close the parentheses twice. And this is our factored form. And therefore, those are my other zeros, guys. My other zeros up here are x equals 1 plus square root of 2 and x equals 1 minus square root of 2. And both of these have a multiplicity of 1, and it is indeed going through literally both of them. All right, so now we just have to graph it on a piece of paper. I mean, when you graph it in your calculator, you see what it's supposed to be. Now we just have to actually graph it on a piece of paper. So the next parts that you're going to need to graph it on a piece of paper are the extrema. The extrema, there are, well, let's see. What's the degree? Oh, the degree is 4. So there are 3 extrema because it's always 1 degree less or 1 value less. Your y-intercepts, all you have to do is plug in x equals 0, and when you plug in x equals 0, your value is 0, 10. Okay, so these are 2 important things to know. Our end behavior, well, we already know what the end behavior is. If we look up there, it's a parabola. Why? Because the degree is 4 and it's positive, so it is opening up. And so your limit of p of x as x approach infinity is infinity because it's going up to the right. And then your limit of p of x as x approach negative infinity is also infinity because it's going up to the left. And this is our final answers before we graph. And so now, last step, let's graph. And you are literally graphing the amounts you identified. X-intercepts -2 and 5. 1, 2, 3, 4, 5. And my y-intercept is 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then roughly these two values, x equals 1 plus square root of 2 is roughly 2.4, not 2.5. And x equals 1 minus square root of 2 is roughly negative 0.4. So you can put those on the actual graph. So our values are 2.4, which is about right there, and negative 0.4, which is about right there. And we have to make our picture so that our end behaviors are going up on the left. We go down somewhere, go up to the middle, go through and down somewhere else, and go up. How low or how high you go when there's no point does not matter. You just need to make it go up and down, however high or low you feel. But obviously keep it on the graph. Don't be extra. And that is it. So we have concluded our notes for today. I don't know why I'm zooming out. Pay me no mind. And I am done. We will practice next class. Marshall, out.